Hello, students of the Physiological Psychology class. This is Dr. Tausman coming to you live from Roanoke, Virginia. And these are going to be the educational lectures on three topics. We're going to talk about movement in this first one, and then we're going to move on to, what did we have? Sleep and eating as well. What I'll ask that you do with each one of these presentations is kind of type out the summary idea once again. Just listen to these things. Type out a summary. Chapter 8 in your book for the movement one will be pretty important. Print out the agenda, because I'm going to kind of follow the agenda just in a way here so you can hopefully understand things. So we're going to actually start off with movement in Chapter 8 here. First, I want to say that I did very much appreciate the post that you folks did for the discussion board on movement and Parkinson's disease. I'll talk about that a little bit later. Starting off, we're going to actually talk about this idea of mind and body. The idea that the mind and what goes on mentally with movement is very related to the body. If you think about it, movement is a very, very easy thing to do. If you look at that picture I have on the agenda, that's a picture of me about a year and a half ago. I'm standing on one foot. I'm holding my hand up high. I can do all these different behavioral things. So many times in neuroscience, physiological psychology, we talk about behavioral plasticity. Behavioral plasticity, the ability to do a lot of different things very easily. And if you look at that picture, you can see that I've never done that particular behavior before. And so the ability to do that must be somehow based on my brain's neurobiology. That the information in my brain, the pathways and the connections must be very, very interleaved to allow new spontaneous motor behavior to happen so easily. So behavioral plasticity is probably guided by neuronal or synaptic plasticity, neurobiology plasticity, the ability for all these neurons and all these centers in the brain to adapt very easily. So we have that particular example, standing up on one foot, holding something, moving, and even talking at the same time. So we must have a very detailed brain that allows this to happen. The other reflection I just wanted to share with you is that a lot of these behaviors, as far as movement, can be very, very automatic. They happen very automatically. Right now, I'm walking, I'm talking, I'm holding this recorder, and this happens very automatically. And so that can be very good on many occasions. Unfortunately for me, there was one occasion where this was not so good for the automatic processing. And I think I alluded to this in the first section of things. But that day was the day I had my terrible bicycle accident. Biking for me had become very, very automatic. I've been doing it for over 40 years. Got on my bike one morning. Pedaling was very easy, was very automatic. And then suddenly at one moment in time, I was so tired I fell asleep and I lost all motoric function. And the results were pretty disastrous. So it's good to have these things on automatic pilot many times. But obviously, if something goes astray with that at some point, it can be very negative as well. So we have a lot of behavioral plasticity. We have a lot of neuronal plasticity to allow these types of things to occur. So the brain. If we look at the neurobiological plasticity of things, the brain is very well set up to allow a lot of this to occur. Humans have needed to use movement-related things from the beginning of time. The ability to walk quickly, talk quickly. Back in the time of the caveman and so forth, movement has always been very, very important. There are a number of key structures in the brain that kind of guide this. The first structure in the brain is a structure in the hindbrain. It's called the cerebellum, and we talked about the cerebellum, I think, before. But the cerebellum controls motoric functions, and it's the big bump kind of on the back of your head. It's in the hindbrain, so it controls primitive movement type things. The cerebellum can very well be affected when we drink too much alcohol. Alcohol goes into this part of the brain and then makes motoric function potentially very, very difficult. So balance, movement, walking is all controlled by the cerebellum. The other thing that I put in here that you should read a little more about is the idea of the cerebellum in a speed skater. Speed skaters have to be very, very good at motoric function. They have a lot of behavioral plasticity. And in this abstract, if you read through it, it actually says that the brain is very well developed for speed skaters in the cerebellum. There's a lot of connections there. There's a lot of development in the areas. And actually, if you look at picture 2 in the handout there, that's actually a picture of something called dendritic arborization. Dendritic arborization is the idea that in more well-developed brain areas, you see dendrites really start to branch out. And if you look at those pictures in there, the Purkinje cell is in the cerebellum. The more highly developed areas, if there's a lot of dendrites collecting electrical information, this type of neurobiological plasticity with all these dendritic arborizations going on really allows a lot of behavioral plasticity again. So in fact, dendritic arborization in the cerebellum, the dendrites branching out as they do in these various pictures, mostly in E and F, really show that the more dendrites you have, the more branching you have, the better off development is going to be. That's why stimulating little babies early in life can actually be useful as well. It can lead to these dendrites branching out. And the more dendritic arborization you have, the better you'll have behavioral plasticity. So that is the example in the cerebellum. Another structure that's very important in movement is in the midbrain. It's called the substantia nigra, and very connected to Parkinson's disease, as we'll talk about. The neurons in this particular area contain a lot of dopamine, and they also function with a lot of ability to help control movement. The final structure is actually, or the final major structure, is actually in the frontal lobe, the higher brain area. Way in the back of the frontal lobe is the motor cortex. The motor cortex controls all movement-related areas of the body. Higher brain function with that. And so even that picture you looked at with me standing up, that was probably my motor cortex kind of controlling that. And there appear to be some very interesting neurons in the motor cortex. You can read about it more in your book. They're called mirror neurons. These mirror neurons seem to respond very strongly even when somebody else is doing movement. So it's as if these mirror neurons can understand when you're watching other people move in a certain way, and maybe that's helping our brain learn about things. So 3 key areas in the brain. Your book has a lot more and a lot more pathways, but you don't really need to know all those details. The cerebellum, the substantia nigra, and the frontal lobe, specifically the motor cortex. So what I would ask that you do is you can add a few more details from your book, but put all this information down. Probably typed out summaries would be fine, or a detailed outline as well. Either or, actually. Okay, thanks.